Hello, all. This is Madhu Reddy, and this is my friend Nitin. So we both started this journey on the chaos engineering. So the traditional chaos engineering approach had a lot of challenges, which we wanted to solve with our own novelty approach. So we bought an AI and machine learning way of solving this chaos engineering problem. So I hope that everybody having a fair understanding on the chaos engineering side. So so before just a time, this agenda which I wanted to cover is on the introduction on the chaos engineering side, on the game theory, and the game theory based on the chaos engineering systems, benefits, future direction, and the demo and the Q&A session. Before that, if I want to give an introduction about myself, I have 18 years of IT experience. Currently working at the Samsung as a chief architect on the IoTG product development team, and my friend he was part of with me on the previous company where now he started his own journey with Aero NGS. It's a startup company we started solving with this product, and he has a 13 years of experience, and we both are a research graduate, so we are doing a PhD on the cloud computing as well. So this is a brief about our introduction, so let's get started on the chaos engineering side. So I hope that everybody knows on the chaos engineering. So it's just a quick. If nobody knows, then probably I think it'll going to give a introduction that we deliberately introduce a fault in the system to identify the potential weakness and improve the system reliability and the resiliency of the system. The current chaos engineering having a limitation that it identifies the individual component, and only the experiments have been conducted only on the individual components on the CPU surge or the memory usage, and only the chaos experiments would be run. And currently, the platforms which is available on the Netflix, Chaos Monkey, AWS FIS, and Litmus Chaos. All these tools has some kind of a limitations, so which we wanted to solve using a game theory based approach. It's a mathematical based game theory which has a Nash equilibrium. So with the help of this, we can understand. So in the real world, the chaos engineering would helpful in improving the system reliability and the resiliency of the application. So if considered in a distributed application, there are a lot of components would be deployed onto the cloud platforms, right from your database servers, microservices, your applications, messaging queuings, and how the components individually interact with each others. If one component goes down, how the system reacts. All about the individual and the interactions. Only the reliable and the application resilience can be improved. And with this approach, definitely it can be solved. So we have developed a prototype. It's on the synthetic data. So me and Nitin, we both actually worked on the machine learning. So we have built our own data pipelines, which also not only on the AI based, but also on the generative AI. It provides a auto recommendations with also the chaos experiments code would be generated and injected into the systems, not on the individual component. As I said, there are a lot of interactive components, interdependent components, which will be injected. So as I just said that it's about the chaos engineering, the importance. How do we identify the address potential system weaknesses, and how do we improve? All these are part of the chaos engineering. So this is a traditional approach of doing the chaos engineering with all the stress testing, failure scenarios, randomly fault injecting into the systems, incomplete coverage, and lack of strategies. So let's jump into the game theory, and this is where we have used a mathematical formula with the game theory. I hope that everybody is having a familiar understanding on the game theory, how it works. And it's a simple word in a game theory. It's multiple players where each individual interactions will start playing, interacting, and they reach to a stage where the systems remain stable. It can't be done anything. So with the same we have employed, we have between the game theory. So this is a basic concept of the game theory, the players, as I said, strategies. So we have a 3 to 4 strategies which employs in the game theory. The payoff diagram, so which provides that there is no space for improvements, and it's been the systems is stable. And we are using a Nash equilibrium. So it's a state where there is a stable and no player can be modified or adjusted with the system states. So current system, how do we apply it with the current chaos engineering with the game theory? And this is where, so we have a model with the system components, analyze the interactions, calculating the payoff graphs with the Nash equilibrium, and guiding the chaos engineering experiments with the game theoretical model. And we have a continuous learning and adaptation, which has been added to the pipeline. So we have a generative AI as a code. So we used it's a BERT, which ChatGPT's 3.0 framework with a generative AI model, which we used for building this application. And the benefits of using the game theory in chaos engineering is like we can target the experiments. It's not for the individual component. As I said, it's the interactive based components. It can be a multiple components. There is an enhanced system resilience. So you can improvise your system resilience based on game theory. With the traditional approach, as I mentioned earlier, with the individual components, where the chaos monkey, so we target it for an individual component. So it might be a CPU spike surge usage, or the memory usage, or the disk usage. It's about an individual component we talk about it. So optimal resource allocation. So with the help of game theory, so we can optimally allocate the resources rather than scaling up and scaling down the resources. So we can pinpoint the way the system can be improved with the help of the resource allocation. Dynamically adaptability and proactive failure prediction. So this all features will be provided in the dashboard which we are building it. As of now, it's a prototype, but we just wanted to showcase that how the powerful the game theory with the Nash equilibrium algorithm when we employ it with the chaos engineering. So comprehensive method of the for a game theory based chaos engineering is like we have picked up a data preparation. So this is where the data would be ingested. So we have a sidecar patterns for the Kubernetes cluster where we'll be deploying it. Apart from that, we have the other agents which will going to inject into the cloud systems, which provides the facts data and it uploads all this data to the dashboards of the chaos synergy. And this is where the system would be analyzing that about all the systems would be on the visualized platform, each individual component and its dependencies and how it is connected to each other and how the interactions happen. All these things can be visualized over the dashboard. We have a model training as well. So we have a continuous data pipeline. So where it talks to the lot of monitoring systems like CloudWatch, Dynatrace, New Relic. So where continuously the data is fed and it has been trained by the models and with the continuously evaluation. So we have a feedback loop engine as well. And as of now, so we have built it with the synthetic data. All the data is a synthetic, it's not a real-time data. So this is how we prepare this data. So we ingest this data, we provide it to the Nash equilibrium, then it is fed it to the chaos measuring algorithms. And from there, we train the model and the model is evaluated. So this is how the components interaction looks like. So it's a game theory principle. So in real world, any applications would be a distributed application. It would be deployed on the cloud platform and each components would be a multiple. So maybe it is a EC2 instance connected to the databases. And there are some microservices applications which is running on the Kubernetes clusters. There's a network devices, VPCs, subnets. So current chaos engineering is only studying on only the individual components, not on the interactive or the system components, interdependent components. So here we have classified that with an instance that we have 4 components, a component A, component B, component C, and component D. And A component interacts with B, and A interacts with C, A interacts with D, B interacts with C, B interacts with D, and C interacts with D. So all this are the players, as I explained in the Nash equilibrium. So these players will try to provide inject the fault into the systems and try to make it more stable with the Nash equilibrium algorithms. So this is a concept of Nash equilibrium in a game theory. So this is where a no player can improve the system because the system is already stable. So we have used in our chaos engineering. So this measures the chaos qualitatively, that the metric based on the faults which has been deliberately injected into the system, and how each components are interacted have been recorded with all the lower values. By applying this Nash equilibrium, uh, we achieved from unstable and degraded state to the system to a stable state. So we use the AI learning model and with the prediction. So we use this mathematical model called game theory, and we used AI machine learning with the random forester classifier with generative AI to train the data. So as I said, all these data are ingested through our one of those adapter plugins, so which will be injecting all this data to our dashboard systems, and from there it will be sent to the Nash equilibrium algorithm, and from there the game theory will going to give us system states, either a stable state, unstable, or the degraded. And also it provides a recommendation out of it. So it provides that what is that chaos experiments need to be run on the each individual component, and it helps in to observe the potential system weakness, and it can be very useful as well. So this is the architecture of game theory based. So we have a data ingestion layer, we have a machine learning layer, we have a dashboard layer. So Nitin, do you want to?
Yeah, hello. So this is how the simplified sky view of a simple architecture looks like. It's a bare-bones simplified architecture, of course. So you have multiple data sources coming in from, for example, if you can see in the bottom left, it's the CloudWatch. It's one example which is forwarded by Kafka onto the data lake, which then gets forwarded to the ML component, which is responsible for data ingestion and analyzing it. And the game theory predicts how the components talk to each other, how they interact, and try to see where the faults could occur and how it may occur, and so on. And of course, this gets stored in the database, and also the front end layer, which is the dashboard, is where the data gets seen, where the end user can see the dashboard. Yeah.
Thank you, Nitin. So before that, we'll get into the demo part. We have built with a machine learning model. So by the way, this is the product which we are trying to build, Smart Chaos Lab. So we have started a company in India in last month with the name of Aero Ages, and it has all the white papers. So you can just go and check aeroages.com, and with the white papers you can download that what is that we are trying to build on the product. So this is one of the feature. Chaos Synergy is one of the feature of the Smart Chaos Lab, and where we are just trying to provide the cloud agnostic fault injection. So we don't want a vendor lock-in. I think with the AWS FIS, it is a service. Again, it's a vendor lock-in with the chaos. So there is no platform which is a cloud agnostic, so which we want to try to provide it. And there's a AI-driven anomaly detection as well as part of the systems. We are also trying to provide that chaos experiment recommendation. The tools or the platform which as of now it is there, so we have to code it. So either we have to provide it in a YAML or a TypeScript, but we are providing a platform with generative AI. It automatically writes the chaos experiments code for you with this platform. With this script generated, you can use it on any cloud. So we provide a third-party cloud provider plugins right from the Azure, GCP, and the AWS as well. So we have an orchestration. This is a dashboard which has an orchestration chaos experiments where you just have to deploy the plugin or the agent on your cloud platform, and it tries to provide you the architecture entirely on the dashboard. It visualizes that how the each component looks or how the each services look and how it is interconnected with each other. It has a real-time monitoring and reporting services as well. So with the traditional monitoring-based tools like CloudWatch, Dynatrace, what that lacks, the fault prediction system. So we try to use a anomaly detection. So we try to use that fault prediction systems, pinpoint the area where exactly that the anomalies. So either it might be a CPU usage or memory usage. So it provides a real time. So we have used streaming on the Kafka and other things on the pipeline side. Yeah. So this is a synthetic data. So whatever I'm showing is this. I'm just manually trying to input this data, but this would be fed by the plugins. So all this data comes as an input to the systems and it will be visualized. So I just want to give just a glimpse on that how that AI systems recommends based on the components and how these components interact with each other and what is that how we can improve the system reliability and the resiliency. So I just enter the component A as one of the database, a component B as web server, component D as cache, component D as message queuing, and enter the failure condition as connection timeout. All this will come as an input. I'm from the plugin or the adapter, but I'm just giving manually. So this is a fault state. In the Nash equilibrium, this is a mathematical state, either a 0 or 1. A 1 represents a failure state, a 0 represents a stable state. So I'm just entering the random values here, 0, 1, 1, 0, 0, submitting. So it has a generative AI. It understands the failures and it provides the recommendation. So now the predictor system state is a stable, and it says that no recommendations are needed for a stable system. So let's try to provide. So I have some data sets here. So it's synthetic data, as I said. So I'm just trying to get one of those data to provide how the recommendations looks. So I'm entering this component as a web server. This as firewall. Load balancer. Messaging queuing, and then network timeout. And 0, 1, 1, 1, 1, 0, 0. Now it predicted the system state as unstable. And you can see here the A interacts with B and there is a network issue. And it has provided the recommended experiments to run that inject the packet loss into your network between the web server and the firewall. And the second is inject the latency into the network between the web server and the firewall. And third is inject the error into the firewall and configuration. So using with this recommended AI-based recommendations, you can improve your system reliable and resiliency. And not only this, so we are trying to provide with the smart chaos lab with automatically this experiments would be generated. Not only with the recommendations, it also provides a script generation as well. And that can be reused because as it is a cloud agnostic platform. So this was a short demo. The key takeaway is so how you can improve the system resilience with the help of your game theory. And it has a Nash equilibrium and the chaos measure, which is a powerful algorithm in the mathematics, so which we have employed in our algorithms here on the system. We have incorporated all the game theory to identify and making optimal components interaction between and maximize the system resiliency. We have targeted the chaos experiment based on the game theory with the interaction, not on the individual components. And with the chaos, with this game theory, you can able to identify and minimize the downtime of your failures of the system, not with like the traditional approach, chaos engineering. So this is what we wanted to build with the future direction and the applications of the chaos engineering. So we want to expand the scope of the game theory. We are adapting the approach for the different industries and the system types. So we are trying to integrate with the other monitoring and observability tools. So we are trying to come with the more plugins, either for the Dynatrace or the CloudWatch, Neuralink, and automating the chaos engineering with all the AI-driven stuff. And that's it. This is about chaos engineering with the game theory with the Nash equilibrium. Open for question and answers, Q&A. Thank you. Yeah, I can hear you. Thank you.
I wanted to ask, I can assume that a lot of companies are kind of using similar infrastructure, whether it's serverless or hosting the Kubernetes cluster in the
Right.
cloud. So I'm assuming they kind of have the same challenges
Yes.
in dropping packages through network failures and
Right.
such. Is there some solution where you have kind of a out-of-the-box set of failures that are kind of similar cross applications, where I can just take those out-of-the-box libraries, run them against my application to make sure that I have like 90% coverage of very generic issues, and that my application resiliency can stand against those similar issues?
Right. So you can have we are building a platform which is more customizable, and where you can use your reusable with your chaos experiments codes, which covers with all the coverage of 80 to 90%. With the help of generative AI and the model which game theory, it pinpoints where the potential system weakness. So you can identify and improve your system weaknesses, and it's a continuous improvements. It's just not a one time, so it's a continuous improvements where you have to run this game theory. So with the system provided, every day it provides how the system interacts with each other, and it also try to provide, it reaches to a stage where the system which can't be not optimized, it's a state that is called a stable state. And this is where it provides with all the customization and other things. So we have published this white papers, so feel free to reach to the site aeroaegis.com, so which has a detailed about the smart chaos lab. This is one of the feature of the smart chaos lab which we are trying to build it, but the entire platform is called as a smart chaos lab.